As you can see here in the milling operation, it is used for producing the flat surface in a horizontal, vertical and the inclined position. For producing 2D countering such as case of the gears, clutches and 3D contour of the dies and cavity in mold. Then helical grooves in the drills are used for milling operation. Then after milling time, Tm is equal to L plus La plus L0 plus Lc upon F into Z into N, where N is equal to RPM, L is equal to length of workpiece, La is equal to approach, then F is equal to feed, then Lc is equal to compulsory approach and Z equal to number of teeth. From this equation, many times in the GATE examination questions were asked plain milling or the side milling. So the diagram you can see here in the screen. Then cutting teeth on periphery and axis of rotation is parallel to the workpiece surface. In this type of milling, the LC is equal to under root D into capital D minus D. Then after for face milling, the cutting teeth on the face and axis of rotation is perpendicular to the workpiece surface. Then the third one is the symmetric face milling. For this type of milling, LC is equal to 1 by 2 into D minus under root D square minus D square. Then Wi is equal to W. Then after fourth one is asymmetric face milling. So Wi is equal to W plus 2 into offset. And fifth one is end milling. For that, cutting tooth are both side face and periphery or the surface. Then D is equal to W and LC is equal to D by 2 for this type of milling. Then for the straddle milling, it is used to cut the T-slot, and gang milling is used more than 2 slab milling cutters are there. Then on a single arbor, these type of operations can be made. So these are the types of the milling process. Then up milling and down milling processes are there. So for the up milling process, the workpiece and cutter movement are in opposite direction and thickness is in between 0 to the maximum. Then force will be minimum to maximum and feed F is equal to more and MRR will be more. Then undercut may be possible and rough operation is there in the up milling process. Then tool life will lower and wear will be higher. Then strong holding required and strong jigs and fixtures are used for the up milling process. Then in the down milling process, workpiece and the cutter movement are in same direction. T is equal to maximum to 0, then force is equal to maximum to the minimum. Then feed is less and MRR will also lesser. Then better surface finish, then tool life will higher and wear is lower. Then strong holding is not required and normal jigs and fixtures are used in this process. Then these are the some equations which are useful. F is equal to F upon N into Z. Then sin theta is equal to 2 into under root D by D. Then T max is equal to F into sin theta. Then T max is equal to F into 2 into under root D by D. Then T max is equal to 2 into F upon N into Z into under root D by D. Then third one is average chip thickness. T average is equal to F upon NZ into under root D by D. So T average is also equal to T max by 2. Then indexing in milling, it can be achieved by divide the peripheries of the workpiece into subdivisions and n subdivisions are there. Then 360 upon n is equal to angle. And suppose 40 holes rotate, then one time workpiece will rotate. Now coming towards the second operation, which is drilling. So it is the oblique cutting operation to cut the cylindrical holes in the workpiece and made from HSS. Then first HSS blank is forced, then force blank is twisted to increase the torsional rigidity. Then milling cutters are used to make helical grooves called flutes. and fluids are on cylindrical periphery so that chip flows outward easily. Then width of the cut for drilling. So depth of the cut D is equal to capital D by 2 and width of the cut W is equal to D upon 2 into sin beta, where sin beta is equal to D by W. So that after uncut thickness T1 is equal to F by 2 into sin beta. Then LC is equal to D by 2 into cot beta and LC is equal to capital D by 2 into tan beta. Then drilling time TD is equal to L upon Fn and L is equal to T plus LA plus L0 plus LC. Then the last one is the MRR, which is equal to pi by 4 D square into F into N, and for blind hole LC is equal to 0.33 D, and for conventional processes LC is equal to 0.5 D through hole. Then angle between two cutting edge is equal to point angle 2 beta and standard point angle 2 beta is equal to 180. Then beta is equal to normally taken as 59 degree. Then after helix angle between the leading edge of land and axis of drill bit. Maximum helix angle is equal to rack angle of drill bit. After the steel cast iron 116 to 118 degrees Celsius 2 beta. Then for hardened steel 125 degree. Then for brass and bronze 130 to 140. Then wood and plastic 40 to 60. Now the third process is broaching. It is orthogonal cutting tool and primary is used for making keyways. Then now used for several shapes, especially in the automobile and industries. Rise per tooth is equal to each of the tooths slightly higher than the previous tooth. Then gap between two different teeth is called as the pitch. Then here you can see that HR is greater than HS greater than HF. It means the height for roughing is greater than height for semi-finished teeth is greater than that of the finishing teeth. Then for the broach length LB is equal to ZR into PR plus ZS into PS plus ZF into PF. Then depth of keyway D is equal to ZR into HR plus ZS into HS. And the broaching time TB is equal to LB plus T upon VB. Then keyway cutting. Then fourth one is keyway cutting. For that, depth of the keyway D is equal to ZR into HR plus ZS into HS. And for the fifth one, enhancing a hole, Z is equal to D by H is equal to DF minus DI by 2 into H, and D is equal to DF minus DI by 2. So these are the equations for the broaching process. Then after ISO designation of the grinding wheel, there are 6 types. So you have to remember this table because from this table so many times the questions were asked in the exam. Like if first one is the 30 means manufacturer's private marketing, then A is the type of abrasive, then 220 is equal to grain size, then R is equal to hardness or softness, then 11 is equal to structure and V is equal to type of bond. Then the last one 25, once again it is the private marketing to keep the record. So in the types of abrasive there are 4 types. A is for L2O3, B for bonazone, then SiC for silicon carbide, then D for diamond. Then grain size 10 to 20 is coarse, then 30 to 60 is medium, then 70 to 180 is finishing, then 220 to 600 is very fine. Then for hardness, A to T is soft, then I to P is medium, and P to Z is hard. Then for the structure 1 to 8 is dense, 9 to 16 is open. Then after types of bond, So V for vitrified or clay bond, then E for silicate, then R for rubber, and B for bakelite or resonate, and M for metal bond. Then after the last one is private marketing to keep the record. Then there are types of bond in detail here. Then after shaper, slaughter and planer. So in the shaper, tool will reciprocate and feed is given to the workpiece. Then in the slaughter, it is vertical. Then cutting stroke is slow and the return stroke is faster. Then in the planer, the feed is given to the tool and workpiece will reciprocate. So there are some equations also similar to the other operations, like L is equal to L plus LA plus L naught. Then W is equal to W plus WA plus W naught. Then number of strokes, N is equal to W by F, and T1 is equal to L by Vc plus L by Vr. Then after total time taken, T is equal to N into T1, where T1 is equal to L by Vc plus L by Vr. Grinding process. Grinding wheel contains the abrasive grades, and grinding wheel is milling cutter with infinite number of cutting edges. Then each grade is equal to SPCT, means with alpha is between 40 to 60, and SPCT means single point cutting tool. Then in the grinding, it is the combination of the shearing, plunging and rubbing. Then there are types of abrasives. Al2O3, SiC, CBN and diamond. Then there are some properties for the grinding wheel, like grit number is inversely proportional to the grain size, and for grinding hard material, the soft grinding wheels are used. Then there are structures are there, dense and open. And there are two processes are important, like truing. It is an act of the regenerating the required geometry on the wheel before brazing. Then in the brazing process, the glazed and the loaded wheels are turned at its surface so that the fresh and sharp grits are exposed to the workpiece during the grinding process. Then sixth one is lathe operations. In that there are 4 to 5 lathe operations are there. First one is for the plane turning operation. D is equal to Di minus Df by 2. Then T1 is equal to L upon F into N1. Then N is equal to 1000 into V upon pi into D1, and T is equal to T1 plus T2 plus T3. Then for the facing process, T is equal to pi upon 4 into Fv into df square minus di square. Then for solid plate, T is equal to pi into df square upon 4 into Fv. Then for the taper turning process, capital T total is equal to d max into cosec theta upon F into n plus 1 by 2. Then Li is equal to d max into cosec theta. Then T is equal to L upon Fn. Once again, Ln is equal to d max into cosec theta into n, and n is equal to 1000 V upon pi into d1. Then for thread cutting process, external thread n is equal to 25 upon tpc. Then internal thread n is equal to 30 by tpc. Then tpc is equal to thread per cut. Then after gear ratio, gr is equal to pitch of thread upon to the pitch of lead screw. So gr is equal to p of t by p of l. Then gamma is equal to n max upon n min raised to 1 upon n minus 1, where n is equal to 1000 V by pi into d. Then there are taper turning methods. The compound race method includes d is equal to di minus df by 2, then tan theta is equal to di minus df by 2 into l is equal to d by l. And it is not used for the long length, and production rate is lower and poor surface finish in the compound race method. Then in the tailstock offset method, h is equal to l into tan theta, and h is equal to l into di minus df by 2 into l. Then the tailstock is offset and feeded. Then the last one is foam tool method. In this method, a foam tool is plunged into the workpiece to produce a very small taper, such as in case of the chamfering. Now these are some notes for the boring process. If the offset is in upward direction, then alpha effective will decrease and gamma effective will increase. If the offset will be in downward direction, then alpha effective will increase and gamma effective will decrease. Now the last one is the powder metallurgy. It is the method of producing the fine powder material blended and pressed into the desired shape, then heated in a controlled atmosphere. And the manufacturing of powder process, there are 5 steps are there. First one is by atomization, then the reduction, then after third one is electrolytic deposition, fourth one is granulation, and fifth one is sorting. Then 2 important terms are there, infiltration and impregnation. The infiltration, the PM component is dipped into the low melting point alloy in metal alloy and voids are filled by the liquid. Then decreasing the porosity, strength will increase. Then in the impregnation, in this process kept in oil bath, the oil penetrates into the void by capillary action during the actual process service condition, and the oil is released slowly to provide the necessary lubrication. PLU is in CNC machines the length of the work table for one pulse. Output from the machine is defined as BLU. This is all about the 6 chart of the production technology. We have completed all the 6 charts of the production technology. So if you like this video, please do like and subscribe to the BS Academy channel and press the bell icon for the upcoming videos. Now we will start the next subject of the machine design. Thank you so much.